They called it the tallest grave in history. A $1.2 billion skeleton of concrete and rusted steel, frozen in the Saudi desert for 7 long years. Since 2018, the world watched as the cranes sat silent. The billionaire behind it was detained, and the harsh desert sun began to bake the exposed core. The Jeddah Tower wasn't just a failed project. It was a global punchline for overambition. But while the critics were busy writing its obituary, something shifted in the sand. In January 2025, the silence didn't just break, it shattered. The cranes roared back to life, the concrete pumps started screaming, and the world realized it was wrong. The Jeddah Tower is back. It's currently pushing past floor 95, and it's heading for a mark no human has ever touched: 1 full kilometer. Let's put this in perspective. If you stacked 3 Eiffel Towers on top of each other, you still wouldn't reach the tip of this building. We're talking about 3,280 feet of vertical ambition. At this height, the rules of construction don't just change, they break. Right now, as of early 2026, the tower has officially crossed into what engineers call the death zone. Below floor 100, you're building a very tall skyscraper. Above floor 100, you're building a structure that has to survive atmospheric conditions usually reserved for airplanes. We are talking about a pace of 1 floor every 3 to 4 days. It's an insane, breathless sprint to an August 2028 completion date. But there is a reason no one has ever built a kilometer high before. It's not about the money. It's about the invisible wall that physics builds in the sky. At ground level, a 20-mile-per-hour breeze is a pleasant day. At 600 meters up, that same weather system hits the building at 125 miles per hour. That is Category 3 hurricane force, every single day. But the wind isn't the real killer. The real killer is something called vortex shedding. When wind hits a massive flat surface, it creates swirling whirlpools of air on the opposite side. These vortices alternate from side to side, creating a rhythmic tug-of-war. If the frequency of those tugs matches the building's natural sway, you get resonance. This is exactly what tore the Tacoma Narrows Bridge apart in 1940. It didn't just blow over, it vibrated itself to death. To save the Jeddah Tower from vibrating into a pile of rubble, the architects, led by Adrian Smith, the man who designed the Burj Khalifa, had to turn to nature. Look at the footprint. It's shaped like 3 petals of a desert plant. Those edges are asymmetrical. They taper. They twist. Why? Because a confused wind is a weak wind. The building's shape literally shatters. The wind gusts before they can form a rhythm. The tower isn't fighting the wind, it's dancing through it. But even if you survive the wind, you still have to deal with the weight. Jeddah Tower is made of over 500,000 cubic meters of reinforced concrete. Here's the nightmare. How do you get liquid stone to the height of a small mountain? The current world record for pumping concrete is 621 meters. Beyond that, the physics get brutal. To push concrete that high, the pressure inside the pipes becomes so intense, it generates massive amounts of friction heat. Now combine that with the Saudi heat, frequently hitting 115 degrees Fahrenheit. You have exactly 90 minutes. From the moment that concrete is mixed to the moment it's poured at the top, the clock is ticking. If there's a mechanical failure, a traffic jam, or a pump clog, that concrete starts to set inside the pipes. If it hardens in the system, you aren't just looking at a delay, you're looking at millions of dollars in destroyed equipment and a structural nightmare that could stall the project for months. Every single pour is a high-stakes race against time and chemistry, and as they approach floor 130, they are about to hit the absolute physical limit of what a pump can handle. Floor 130 is where the Jeddah Tower undergoes a species change. At roughly 550 meters, the building stops being a concrete monolith and starts becoming a steel machine. Why? Because if they kept using concrete all the way to 1,000 meters, the base of the building would have to be so massive there'd be no room for elevators or offices. The tower would crush itself under its own weight. But the handoff at floor 130 is the most dangerous engineering feat ever attempted. You are taking a rigid concrete base and mounting a flexible steel spire on top of it. These two materials behave completely differently. Steel expands and contracts rapidly in the sun. Concrete is slower and more stable. They vibrate at different frequencies. Engineers have to marry these two systems together with millimeter precision while hanging half a kilometer in the air. One tiny misalignment at floor 130 could translate into a 10-foot lean by the time you reach the 200th floor. The tower's entire destiny depends on this single transition point. Would you trust a math equation enough to stand under 400 tons of steel being bolted onto concrete in 100 miles per hour winds? Let's talk about the one thing no one thinks about until it fails: the elevators. In a normal skyscraper, elevators use steel cables. But steel has a problem. It's heavy. Once a steel cable reaches 500 meters in length, it becomes so heavy that it can no longer support its own weight, let alone a cabin full of people. It would literally snap under the gravity of its own mass. To reach the 160th floor, the Jeddah Tower needed a miracle. They found it in Finland. A company called KONE developed something called UltraRope. It's a carbon fiber core wrapped in a high-friction coating. It is 90% lighter than steel. Because it's so light, the elevators can travel at 22 miles per hour. You can go from the lobby to the highest observation deck on Earth in 52 seconds. That's faster than most cars merge onto a highway. But more importantly, carbon fiber doesn't sway like steel. In high winds, traditional elevator cables start to swing like jump ropes inside the shafts, forcing the building to shut down. UltraRope is so stiff it stays rock solid. The Jeddah Tower isn't just a building, it's the world's first functioning space elevator prototype. Building to a kilometer is one thing. Living there? That's a descent into madness. Think about the most basic human need: a glass of water. In a normal house, your pipes use city pressure. In the Jeddah Tower, you're fighting gravity every single second. To get water to the 160th floor, engineers have to pump it through a series of high-pressure transfer stations. If they sent it all at once from the bottom, the pipes at the base would literally explode from the weight of the water column. And then there's the waste. When you flush a toilet at 800 meters, that waste has to travel down nearly a full kilometer. If it fell straight down in a simple pipe, it would hit the city sewers with the velocity of a cannonball, destroying anything in its path. To prevent a literal sewage disaster, the system uses a series of zigzagging baffles and specialized pressure brakes to slow the descent. Even your bathroom break at the top of the world requires a masterclass in fluid dynamics. The air at the summit isn't like the air at the bottom. At 1,000 meters, the air pressure is significantly lower. This means the Jeddah Tower has to be hermetically sealed and pressurized like a Boeing 747. If a window were to break at the top, it wouldn't just be a draft. It would be a life-threatening decompression event. Then consider the temperature. In the Saudi desert, the ground might be 115 degrees Fahrenheit, but at the tip of the spire, it can be 20 degrees cooler. The building actually experiences two different weather systems simultaneously. The glass facade has to withstand massive thermal expansion, expanding and contracting by inches every single day as the sun hits it. It's not just a building anymore, it's a vertical space station anchored to the sand. Why do this? Why spend billions to fight physics and risk global embarrassment? Because this isn't just about architecture, it's about power. For over a decade, Dubai's Burj Khalifa has been the undisputed king of the sky. It is the crown jewel of the UAE, but Saudi Arabia is currently undergoing its own radical evolution, Vision 2030. Crown Prince Mohammed bin Salman isn't just looking for a record, he's looking for a statement. The Jeddah Tower is the centerpiece of a $20 billion economic city. It's a signal to global investors that the center of gravity in the Middle East has shifted. But Dubai isn't sitting still. Rumors of the Dubai Creek Tower and new mile-high designs are constantly surfacing. This is a skyscraper arms race, where the weapons are cranes and the battlefield is the stratosphere. If Jeddah stalls again, the loss of prestige would be more expensive than the building itself. Failure is not just an option, it's a geopolitical catastrophe. The clock is ticking toward August 2028, but to hit that, everything has to go perfect. And in construction, nothing ever goes perfect. We've seen sunk cost projects fail before. In early 2026, Saudi Arabia had to pause other massive projects, like the $50 billion Muqab Cube, due to financing feasibility. The world began to whisper, is Jeddah next? But you can't hide a half-finished kilometer-high skeleton. The political cost of walking away now is too high. Higher up, the risks explode. A single sandstorm can shut down the site for a week. Oxygen is thinner for the workers. The UV radiation is 20% more intense, and the sway of the building makes crane operators literally seasick. At 900 meters, you are on your own. If a crane malfunctions there, you can't just bring in a bigger one to fix it. You are at the edge of the world. If they succeed, if that final piece of the spire is bolted into place in 2028, It will change our definition of possible. We will have a structure that stitches the earth to the heavens. It won't just be a trophy for Saudi Arabia, it will be a blueprint for the future of humanity. If we can build a kilometer high in the brutal heat of the desert, we can build anywhere. So here's the billion-dollar question. Do you believe they'll make it? Is the August 2028 deadline a realistic goal? Or is it just another piece of PR for a project that has already died once? History is littered with tallest buildings that never reached the finish line. But the Jeddah Tower has already survived 7 years of silence. It has already beaten the critics once. Right now, as you watch this, another floor is being poured. Another steel beam is being hoisted into the wind. The world is watching. Physics is waiting. Drop a comment below. Are you Team Success or Team Tower of Babel? Will we see a 1,000-meter celebration in 2028? Or will the wind have the last laugh? Subscribe and turn on notifications to follow the climb, floor by floor. Thanks for watching.